Welcome back to MAT 101. I realize this is weird. It's weird for all of us. We'll do our best to get through this material and to use this math class as an excuse to try to understand all the quantitative information that's coming at us through the news. In some sense, this pandemic, while it points out lots of things, it points out the need for quantitative literacy, understanding quantitative information, and quantitative reasoning, which is making informed decisions from quantitative information. If you haven't looked at the amended syllabus on Blackboard, please do. If you haven't watched the video going over it, please do. The course structure from now on is quite a bit different, hopefully simpler, more straightforward. Trying to make this as easy as I can on you. You still have access to all the slides. All the Top Hat lessons will stay open, though they won't count for credit after each week, but you can always review them. Let's jump into it. Sorry. So, there's a lot of topics I could have started with, and I've decided to start with exponential growth, because we are still early on in the growth of these cases in the US, though they're already ramping up quite a bit. So in exponential growth, it has a colloquial meaning. That is, in our everyday conversations, we might say something. I've heard public officials say things like, crime has decreased exponentially, when it certainly did not. It just decreased kind of quickly. We use the word exponential to signify some rapid change, increase or decrease, when we usually don't have the information to mean that literally. So here are a couple examples of or just maybe do one, of how you could have rapid growth that's not exponential. So suppose on January 1st, I gave you $1,000. And every day of the year, I gave you $1,000. That's a lot of money. By the end of the year, you'd have $365,000. It might be tempting to say that your checking account is growing exponentially, but it wouldn't be. This is not exponential growth. And it doesn't matter how big that 1,000 is. If it was $10,000 a day, $1 million a day, it wouldn't matter. None of those are exponential growth. Those are linear growths. It's constant. It's the same amount every day. Go one day, get $1,000. Go one day, get $1,000. That's linear growth. It's constant growth. Exponential growth, on the other hand, looks more like this. Suppose on day one, I gave you $2, and on day two, I gave you $4, and on day three, I gave you $8, and on day four, I gave you $16, and so on and so forth. But the last day of the year, that's supposed to be 2 to the power of 365. By the last day of the year, you'd have 7.5, I'd have to pay you 7.5 times 10 to the 109th power. That's a ridiculous number. It's a 110-digit number, and there's literally not enough money on the planet to ante up. So that's exponential growth. Starts small, ends ridiculous. And I wrote out the number without the 5, 1, 5, 3, 3, 6, 2, etc. at the bottom there. Exponential growth sneaks up on you. To eliminate this, I'll tell you a classic story about the origins of chess. Well, so it goes. So, story goes, there was this king somewhere in Southeast Asia, King Shahram, who was bored, wanted a distraction, wanted something fun to do, and so created some sort of contests, invent something clever, and I'll reward you handsomely. And so this wise man, Sisa ibn Dahir, creates chess, brings chess to the king's court, shows the king how to play. The king's overjoyed, thinks this is just the greatest game ever, and tells Dahir, look, you can have anything you want. Name your price, castles, fiefdoms, gold, jewels, whatever you want, I'll pay it. I'm so happy about this game. And so Dahir makes this clever request. He says, all right, I'm a simple man. Here's what I want. So a chessboard is 8 by 8. And on the first square of the chessboard, I would like 1 grain of wheat. And on the second square of the chessboard, I would like 2 grains of wheat. On the third, I would like 4. On the fourth, I would like 8, then 16, then 32, 64, 128. So this would be the first row of the chessboard, right? So, and the idea is that each square after that, you just double the number of grains of of wheat, rather, that you place before it. The king laughs, calls the heir an idiot, and says, "You fool! I would have given you my entire kingdom if you'd asked for it. But you just want a bag of wheat. Fine." And he calls his, whatever guy was in charge of wheat. Guy brings out some sacks of wheat and begins counting. Right? And this seems quite fine. This seems like the wise man is not asking for that much. And so we go to the next row of the chessboard, right? And we start, seeing how that changes. So we get to the end of the next row of the chessboard, and we're at 32,000 grains of sand. But whatever, that's like a bag of, not sand, sorry, but wheat. It's like a bag of wheat. That's fine. The king has plenty of wheat. If the wise man wants a lot of wheat, then whatever, So let's keep kind of going through here. 20 squares in. It's actually 21 squares. Put a typo. You had 1 million grains of wheat. 30, not even halfway across the board. You're at 1 billion grains of wheat. This is exponential growth. What's going to happen in the next square? Well, that was 2 billion, and then 4 billion, and then 8 billion. So once exponential growth gets going, it's ridiculous. It's relentless. 41 squares in, trillion grains of wheat. 51 squares in, 1,000 trillion. 61, 1 million trillion. And 64, they shouldn't have gone that far, I should have 63. It's 18 million trillion. And as best as I can estimate, it's about 1,700 times as much as the global wheat production in 2015. This was just the last square. It doesn't consider all the squares beforehand. So just the last square on the chessboard is far more than modern productions worldwide. So the story ends in one of two ways, either with the king losing his kingdom and the wise man ruling sagely in his absence, or the king just has the wise man executed. So the second one seems more plausible to me. But the story illustrates, and it's an old story, illustrates this shocking behavior of exponential growth. It sounds kind of idiotic to request so little, but by the end of the chessboard, you bankrupt the entire planet many times over. All right. So let's talk about how we calculate exponential growth. This is some questions I'm going to ask you. Actually, maybe I'm going to pause here and I'll start with this slide again in just a minute.